Students, I'm going to give a brief note on chemical kinetics and then go on to problems. Firstly, in chemical kinetics, you have the very first definition, rate of reaction. Okay, so what is the rate of reaction? Rate of reaction is the change in the concentration of reactants and products per unit time, either reactants or products. So your rate of reaction is represented as V is equal to plus or minus dC by dt. Here dC is a change in the concentration and dt is a change in time. Plus will be represented for the product side and minus sign will be represented for the reactant side. Okay, so for example, I give you a equation N2 plus 3H2 gives rise to 2 moles of NH3, right? So N2 plus 3H2, this is the rate of disappearance, and this is rate of appearance, or you can say the rate of formation, appearance or formation. Okay, now the rate of disappearance of N2 will be written as minus change in the concentration of nitrogen per unit time. Then same way, the rate of disappearance of H2, that's hydrogen, will be represented as minus change in concentration of H2, or you can write as minus of 1 by 3 change in H2 by dt. And now what's the formation of ammonia? Formation of NH3 will be twice the formation of nitrogen. See how it is, because we write minus dt is equal to minus half NH3, right? It's going to be D. So here NH3 will be twice of N2. NH3 is twice N2 formation. This is okay. See, this is a question asked. What should be the rate of disappearance? The rate of disappearance of C, and this actually what's the rate of disappearance of B, and they have given a rate of disappearance of A is 10 power minus 2 mole liters per second, and the reaction given is the equation, A plus B gives rise to 2C, and they have asked rate of disappearance of B and rate of formation of C. See, what we know normally that from this equation, that minus of dA by dt is equal to minus of dB by dt is equal to plus half of dC by dt. So what you can write for rate of disappearance of B is that you can, this one, that's dA by dt is equal to minus dB by dt. Therefore A is equal to B. That's the rate of disappearance of A. Now what's the rate of formation, or you can say it as appearance of C? What you can say is that see, from here minus dA by dt is equal to half dC by dt, right? By dt is equal to half dC by dt. So A is equal to half C, or you can write C is equal to 2A. Therefore C is equal to 2 times A is given as A is equal to 10 power minus 2. So This is the answer. 0.02, whatever you get. This is the rate of formation of C. This is the second question. They have given the equation 2a plus b gives rise to 2c, and they have told that they are asking show a decrease in the pressure from 120 millimeters to 100 millimeters in 10 minutes. Okay, and they are asked the rate of appearance of C. That's a 2 millimeter per meter, or 4 millimeter per meter, or 10 or 12. Okay, see now. Suppose you take 2p as the pressure of C after 10 minutes. And there will be a fall in pressure of A is equal to, will be 2p. A will be 2p. Same again, fall in pressure of B will be P. Fall in pressure of C will be 2p. Now adding all three, you get 2p plus p minus 2p, you get p, which is equal to, they said the decrease in pressure from 120 millimeter to 100, that is subtract, you get 20 millimeter. So P is 20 millimeter, and we have told in the starting that we consider 2P as a pressure of C after 10 minutes. So C is 2P is equal to 2 into 20 meters is equal to 40 millimeters. And they have asked the rate of appearance of C. Rate of appearance of C is, so they have given millimeter per meter. So what is the answer? C is equal to 40 by 10, because 10 is the minutes given here. So you get 4 as the answer. So B. Okay, next topic is instantaneous rate of reaction. What is instantaneous rate of reaction? It is the rate of reaction determined at a specified time or a specified concentration, and this is called instantaneous rate of reaction. See now, I have drawn a graph. This is the y-axis represents the concentration and the x-axis represents the time, and I have drawn a curve like this, and the tangent, and then I draw a tangent like this. So the instantaneous rate at any time is determined by the tangent at a point on the time concentration curve corresponding to the specified time. Now a slope of tangent at a point is given as dc by dt, or limit delta t is equal to 0, delta c by delta t is equal to dc by dt. Now minus sign represents the concentration of the reactants decreases with respect to time, and a plus sign will represent the concentration of products increasing with respect to time. Okay, this is the